data type, where in this dissertation actually we used the tag data and the image data, so we can further include another kind of data. And also we believe that by utilizing the social media data, actually there will be always a new opportunity to discover new information about the user based on the data that generated in different media sources. So I think this is the end of the presentation.
Okay, thanks so much. And any question or comment?
Any question? Yes.
Yes, go ahead.
You selected some 5,319 for as a test set, test data, right?
What?
In 48 slide. Go back.
48?
You selected
He was talking about the data set that we have.
training data and the test.
The data set,
That slide.
the beginning,
No, not in the beginning.
no more.
Talking about this
Yeah,
one?
yeah.
On what basis you selected the 119 users as testing set data?
Which one? This one?
Second point, yeah.
So this is, as I mentioned, this is a benchmark data set.
Okay.
So they divided this database. The person that he collect this data, actually, it's divided to the training set and the testing test. So what do you mean by and? I did not get the question.
No, like testing set based on the testing set result you will apply on the training set, right?
Yes.
So on what basis you selected 519 users and 1,000 tweets as the testing set of data?
In what spaces?
On like
Because this is like you get.
Whether randomly select, or is there any criteria, or how did you select
testing set?
the test user and training user? That's his question.
So I'm not sure about the criteria that they use, because this is an in-exist data set.
So
So
it was already given.
yeah, it's already given. This is a benchmark data set actually. So
I think that's also a good question. So you can randomly recreate the
Yeah.
training data set, and if they provide the ground truth from the testing, you can mix up and apply.
Does any researcher use the same data set before?
this one?
Yes, the first one.
Yes. This
Yeah,
is,
because this is my,
yeah, this is the data
interest.
set
Because the
used-
same one, the previous researcher, he used this same data set
Yes, this
and
is
came
the-
out with this result. And compared the same, his technique with the other guy technique, and coming out with a new improvement in his technique. The previous one was like you said 10%, and this is 50%. You are talking about like 40% different, This is a good idea. But you have to explain to the, for tomorrow, if they ask about the data set, say they are used it before. You don't know. Get ready.
Okay.
Any
Yes,
other?
sir.
Any other question?
Yes. Go ahead.
Let's say if an image is not tagged by a user, then how can we get the text information?
If what?
If an image is not tagged by the user,
Okay.
then how can we
So for that part, actually, we used a semi-automatic tagging system that I explained before, which is the Kiwi, that they can produce a keyword for the images based in similar images, actually. So we did not implement a semi-automatic tagging system. We used an exist system that used to give a tag to the images.
Generate tags.
So that is
for
the
each-
drawback of the previous approach. Previous approach used rely on the tagging information, but as you said, what if the user didn't tag, or sometimes I can tag the image for this is the Obama, which is not related to Obama. That means the tagging accuracy of the tag user tag is not that accurate. It's a very subjective. So that's the reason we try to use the help of the semantic, the annotation system.
Yes.
What if in the start you mentioned that you can identify the gender from the image's color or something?
Yes.
What if as you have categorized that maybe if a pink color, then for a female, I specifically don't like a pink color, then how?
Yes, of course,
what is the
there is a
criteria?
possibility
Yeah,
that, yes,
yeah.
this is just an example, but there will always a possibility that where you will find, like, you assume this colors, for example, for a user, but you will predict this as incorrect, actually.
Yeah.
Yeah. So this is just an example, like how based on what we can use or mine the kind of multimedia data, actually. Okay.
Okay, thanks so much. Thanks so much. So good luck for your dissertation. I think without the break time, I'd like to continue today's lecture. Then after I quickly finish today's lecture, after a short break, we will continue the first exercise lab for the art programming. Okay. So if you wanna go to the bathroom, it's okay. So I will continue today's lecture. So the last week we had discussed about the association rule mining. So mostly the support vector machine. So there are several other classification classifier. The algorithm we will quickly go over. So frankly speaking, I didn't use the other approaches, but you can get the idea. So just in case you need to, each one has their own strengths and shortcomings. Also, if you realize such the benefit or the disadvantage later when you encounter certain problem, you should be able to adapt to such an idea at the time you can fully implement it. One of the first approach used in the classification classifier is the associative classification. It's nothing but why don't we use the frequent data mining for the classification? So thanks so much. Okay. Classifier. So what is a classifier? The classifier means if we have something, the algorithm or the rule or the something, then from the incoming data we'd like to classify. We'd like to assign a certain class. That is a classifier. So in that case, if we can use the frequent data, so just like the decision tree provide a very simple approach to generate the rules. So using such a rule, we can don't have to. You can just focus on the slide. Okay. I usually moving around, so don't worry. So just like the decision tree, if we can create the rules, okay. So we can use such a rule for the classification. So from the frequent data mining, we can understand the frequent data mining in case A happen, then B. That is the basis of the rule. Okay, so we can use such a frequent result of the frequent mining to create the rule. So which is called kind of the rule-based classifier. Okay, that's the idea. Okay, sometimes the accuracy of such associative classification is better than the decision tree. Decision tree try to focus on the maximize such information gain. Okay, so it try to focus on, but frequent data mining, the frequent mining is most frequently happen the condition. So sometimes the accuracy, so in certain case, not in general, certain case such the associative classification is better than the traditional decision tree. Okay. So these are the variation of the associative classification method. You can find the more information from the published literature. Okay. there are some the empirical results, so you can use them. The next one is a lazy learner. Nowadays, when I attended the dissertation, PhD dissertation presentation, like what Mohammed did just before, many of the candidates they use the classifier, especially the classification classifier. One of them is the lazy learner. So lazy learner is one of them. So we will see what is a lazy learner, and that means there's an opposite of the lazy learner. What is the opposite of lazy? Diligent. Diligent. The eager learner. The lazy learner is just wait. Okay, during the training time, nothing. But during the testing time, then because it's lazy, nothing do during the training. But for the testing, do a lot of job. Comparing to the. But the eager learner means try to find the rule or something classifier, something clustering or whatever. So try to find the rule from during the training time. Okay, that's the main focus. Then the testing time is simple, just apply such a rule. What we have done so far are belonging to what? The lazy learner, eager learner. It's an eager learner, right? So we try to apply the bunch of testing or the conditional probability or the information gain. Try to find something good. Okay, so we eager to find such a rule. Unlike such an eager learner, lazy learner is just nothing to. So, for example, the reason why it's called the lazy is during the training time, it's not much. So minimally process, like the pre-processing step. Okay, we just leave as it is. Okay, but for example, it's called the instance-based learning. So which means K nearest neighbor approach is one of the popular example of the lazy learner. Actually the K nearest neighbor KNN approach is used for what? It's a query to find the similar one K nearest data. Okay, using which means the K depends on the K, so 5 the nearest neighbor. So we try to consider the 5 nearest neighbor as a class. So for example, 1, 2, 3, 4, 5 are the class. This is the kind of the classifier. So when the new test data is coming, then this test data will check the order, which one will be the similar class. So during the test time, nothing do, but during the test time, so this is my class, then based on this class, whether this test data belongs to this one, which one is the most similar class, okay? Or sometimes it can be one nearest neighbor, so consider only one data. Like so it's called the Polaroid diagram. So anyways, consider only one. Okay, otherwise it's the K. However, the K nearest neighbor use what? Metric space. Metric space is you can make the order of the data, like the Euclidean distance measure. Euclidean distance measure, for example, if the main difference between the metric space and non-metric space is inequality. Okay, for example, the distance between him and me is shorter than the distance between him and me plus he and him. Okay, so that is the inequality, which means we can make the order of the data. In other words, we can use the index. So Euclidean distance is the most popular one used in the K nearest neighbor due to the nature of the K nearest. Which means, what about the similarity measure? For example, I'd like to find the 5 most similar as me. Okay, then we'll consider as a class. Then you'd like to find the 5 similar. Okay, at that time we can line up which one is the most, we can line up for that. That means if he belongs to me, that doesn't mean he is not similar as her. Okay, in terms of similarity measure, because similarity measure, we cannot say the inequality, the matrix. Okay, the similarity, even though he is similar as me, he may have a chance to similar of the other class. So it's hard to say that the data belongs to only here. This data can belongs to another class. So k nearest neighbor usually used in the metric space, like the Euclidean space. So that is the reason k nearest neighbor has a problem when you have the high dimensional data. Okay, as we have learned the course of dimensionality. So like for example, it's a 2-dimensional data, 3-dimensional data is okay, but what if the 10-dimensional data? It's very hard to say which one is important to calculate the distance. Distance means it's similar. Sometimes very hard to say when you have the high dimensional data. But I have seen the couple of examples who use just the k nearest neighbor classifier, okay, as one of the classifier in image processing, for example. Image processing definitely based on the similarity measure. It's not the Euclidean distance. So at that time, you may not get the full benefit of using k nearest neighbor. Okay. So what if we have something categorical or symbolic data at that time? So instead of the instance, the item by item, the comparison, why don't we consider the case, like the symbol itself, whether they are similar or not? The case-based the reasoning, lazy learner, is another one. Okay, so when you are using such a k nearest neighbor classifier, you should be careful whether your data is feasible for that kn. Okay. This case-based reasoning, the CBR approach in case of the symbolic data. Okay. At the time that you should have because we cannot apply the Euclidean distance or the metric space, you should have the similarity metric. But it's very hard to find the define. Even the proposing the similarity metric is the one of the research, one of the contribution in your data set. Okay. Cosine similarity is used a lot, and also in general it's called the Mahalanobis, the distance measure, Mahalanobis, but you need to define the covariance metric for each feature, how much they are correlated. Without that information, it doesn't make sense to use the similarity metric. Okay. There are other the classifier, generic algorithm, which was very popular maybe 10 years ago, 15 years ago. So genetic algorithm has been used a lot, but I never used, but the idea is we try to get the idea from the biological evolution, like the mutation or the something like that. So what if we have something, the data, so it can have as many combinations, okay, as possible using the bit, the string of the bit, okay, then prune out some unrelated data. So still anyway, any kind of the classifier data mining algorithm, as I said, is based on the frequency. If that happens a lot, what important, that will be selected as a rule or classifier or the clustering the core function. It's the same thing. So we try to make as many the spring out the population, then we will test it. That is the survival of the fittest. It's kind of threshold value or something. It's similar as the confidence or the support level used in the frequent data mining. Usually it's said it's slow, but there might be way to make the parallel processing. Okay. Such, discuss a little bit of topology. Instead of the hard membership, you can consider soft membership using fuzzy set approach, fuzzy membership. Okay. What if we have the multiple classes, so which means not either positive? Usually, the data mining classifier has been developed based on the statistics. In the statistics, it's called the hypothesis testing, whether true or not. The hypothesis is whether this is the positive or negative. So it's called the hypothesis test. Then that is the two class, true or false, or the positive or negative, something like that. What if we have more than two classes? Then we can learn for each class, for each class, or sometimes for each pair of classes, something like that. We can generalize such a two-class problem to the multi-classes. Semi-supervised classification is in between the clustering and the classification. So we can use something labeled data for the classifier and test it and decide to use them as the training also. Okay, so that is called the semi-supervised classification. I don't know much about the active learning. But why don't you study? I don't know much about the active learning. And this is the transfer learning. It can be applied for, as I suggested last time, why don't you try to transfer the data set, different domain, then try to learn. Then sometimes it works very well. Also, you can consider the different task, so transfer learning. Okay, so far we have discussed three main data mining algorithm. Data mining, okay. Then the next one is the clustering, so unsupervised learning, and the last one is the supervised learning. It's a classification. So I know that those are not enough. Because it's mostly the traditional way of the machine learning and data mining technique. On top of that, there are many barriers, the variety, or some enhanced one. So, however, to understand the state of the art of the data mining, so without understanding the traditional, it doesn't make sense. So also, as you have seen in the previous format, the presentation, he used a couple of the classifier. So that we discussed last time, the line equation as well as the support vector motion. So when you apply this one I have seen a lot of the candidates without understanding, just because of the popularity, many people are using, they just apply the navigation to that. So you should have the justification. Also, you should be able to find the best one. In case you can find the problem, you should be able to enhance such the existing algorithm. Also, sometimes we need the similarity measure, different feature. Even some of the research only focus on the features. Okay, that determines it doesn't matter whether you apply the support vector machine or even the frequent mining. It totally depends on what kind of feature you are going to select. Okay, for example, from the video data mining or image data mining, or the very complicated data mining like the time series data, or social media data is also the same problem. How to characterize the problem? It's not like the X and Y coordinate value or the two-dimensional data. It can be like considered as the set of feature vector. Okay, so such a characterizing the problem is very difficult nowadays. So to do that, you this kind of classifier is just basic, and on top of that you can propose your new idea. It's the same thing in your the project. In the project, so probably you will consider one of the classifier or the clustering algorithm, or sometimes the frequent data mining, like the random forest algorithm or whatever. But the feature, how to characterize your data set, even though you are using the Twitter data set, the naive way is you can just consider graph data structure. Even for the graph data structure, there might be different way to define the node as a tweet to user. Okay, so you can focus on sometimes the event, location, or the different. So why don't you think about to make the details of your problem using the knowledge that we have discussed so far. So we are going to have the 10-minute break. After that, did you guys bring the laptop or any computer? Is there anyone who do not have the computer? So you don't have computer? So you can use the computer if you want. Okay? So then you will be the
team leader.
instructor. I'm going to explain. Okay? If you want to, you can use that. Anyone else? Okay, so after 10 minutes break, why don't you, if you do not install the R programming yet, why don't you try to install? You need to download the 50 to 60 megabyte, okay, data, so file. So why don't you install right away?